So the next thing we do is split the data into training data and validation data, and this is reasonably standard for all of these AI type systems. So what we can do is we can create this variable n, and we can just say that it's like the length of the data. In fact, I believe, did we use, have we got a value for length of the data? Or we possibly just use len of data. I'm just scrolling back up to have a look. I've gone far too far there. That's the len of the number of, I think we could use vocab size actually. So let's just take that. It might just be vocab size there. Oh no, because that's the size of our vocabulary. We want the length of the whole data, which is, if we scroll down a bit, yeah, it'll be all of this data here inside the tensor then. So we're going to split our training set up by the data itself. So let's just do that. We take the length of the data, but we want to take like 90% of it. So let's do that, times by 0.9. But we need to get, because if we did do this, then let's print n over here. We get this decimal, so we need to convert that into an integer. So int of the length of the data times by 0.9, so that we get an integer value of it. And the other side of the other bit of the data will be the validation data. So that's what we're going to get. So let's just set our, we'll call it the training data. Train data is equal to data, and it's all the way up to, so it's everything up to n. That will be our training data, and our validation data is going to be the balance of it. So it's going to be data from n and onwards. And just remember that over here, this one here, when we talk about slicing lists, this one here is, if I just write it above, I guess, if we have a list here, this one here is inclusive, and this value here is exclusive. So when we say n, when we say n here, whatever the number is, if it was like 10, it will be index number 9, so you don't count the 10. But here, when you say like 10, you actually mean 10. So we've got an inclusive, exclusive, and it's actually quite convenient that way for two reasons. Number one, anyway, all arrays or lists start with element 0, but number two is that we wouldn't want the overlap. So if they were the same number, so if this one here wasn't 1 before it, then we'd have to do like n minus 1 and n plus 1. So that's our training data and our validation data. So we kind of like split it into two parts. And the next thing that we're going to do is, like, if we can imagine sort of like reading through this, you could sort of like look at the numbers, but when we've got like number 18, our next value that we're seeking is number 47. And if we had like, let's just say we had, you know, this, well, if we took 18 and 47, our next number is 56. And if we took 18, 47 and 56, our next prediction from it is 57. And we're going to do this for like a specific amount of block sizes. We're going to take chunks of the data, and the reason why we've got to take chunks of the data is because there's a million, you know, there's a million and a bit, whatever the size is here. There's 1.1 million values that come in, so we can't read it all in one go. That would be like a humongous bit. But what we can do is sort of like capture like lumps of data like that. and then predict up to that size, and then to like predict the next one. So we can do like lots of batches, and we can keep going through doing lots of batches, and that way the computer will handle it without frying the processor effectively. So that our choice of this I guess it's kind of like up to us. I think generally speaking, and in the video I saw the it was 8 was used for like effectively the block size, which is, or the chunk size, or whatever we wanted to call it. It's kind of like used up to number 8, but I guess you could use smaller ones, and you could use larger ones, so long as you didn't like go too high up. But if we just do that, we can set block size. So we're creating this variable block size, and we set it to be, say for example, the number 8, and we can play around with this and sort of like investigate and see what happens. But then we can say that our training data, let's have a look there. So we could look at our training data now. So we could take trained data this time, but look at it up to the block size, and then +1. And if we just take a look here, now we get this tensor, and this is actually the first part here going up to, let's just shrink this a little bit out of the way. In fact, I think I can remove the GPT variable. We don't need it up at the moment. This list here, 18, 47, it goes from 18 and 47 to all the way to 58. So this is those are the same effectively. So that's what the training data actually looks like. So now we're going to do the example of, I'm just calling it the example of the block loop, where we're going to kind of like go through these little chunks of data and kind of like read it. So when we've got 18, we've got 47, and then we've got 18 and 47. The prediction's going to be like 56. And when we've got 18, 47, 56, the prediction is going to be 57. So we're able to like construct these little chunks, effectively, these little blocks, and we're going to be able to predict from the little blocks. And we're also going to be able to predict for like this prediction here is like one character, whereas when we've got this whole sequence of characters, this 58 is predicted out of the sequence. So you've got 7 preceding characters here, and we get 58, and we actually see a 58 in here, and that occurs after these 4 sequences. So whatever 58 refers to, and we can kind of like look it up here if we scrolled across enough, all the way across to 58, the letter T, we get the pattern of where that occurs. So T occurs after like this sequence of letters, and it also occurs after this sequence of letters for the purpose of prediction. So let's just do an X equals, and then we're going to call it, we'll just say we're going to call our train data, so our training data, and we're going to go up to the block size, so everything up to the block size, and then we're going to set Y is equal to the train data also, and that's going to be the one before it basically, or also the one after it. So 1 up to the block size +1, so that will look at the next one, and then we're just going to loop through that. So for T in range, and then we look at the block size, because that's what we're doing the loops for. So we're looking into this block size, and here we're just going block size +1, but we're starting from number 1, so we kind of like shifted it 1 across to the left effectively. So if X is all of these there, for example, then Y will be all of these over there, the next set across. That's effectively what we're doing in the by setting these X's and Y's accordingly. And then so we have these other variables that come out of it. So like C is equal to X of, and then T +1. And what's this actually referring to now? We're kind of like, we're looking at X, which is this the training data, and the training data is the training data here is going up to our block size now. So we're looking at this small chunk of code, this small chunk of the tensor inside of it, and we're looking up to the training data part of it to t+1, and for the target bits, so target parts, the target bit will be y of t. So yeah, that will pretty much sort that out. And what we can then do is we can actually print this out. So we can do a print of, and we'll call it like it's our context, and then here its context will be C, and that will kind of like give us some target, which is equal to, and then it'll be target. So it will look like this, and if we run this little piece of code now, what we get is kind of, it describes it better than me talking about it in a way. But when we've got 18 in our tensor, so when we've only got one character, the next character predicted. So if we've got character number 18, next character predicted is 47. And if we've got characters 18 and 47 predicted, or available, then we're going to predict 56. And if we've got these three characters, we're going to predict 57. And we do that all the way up to the block size, well, one less than the block size. So when we've got up to 47, so it's all of these. The prediction is the next one, which is 58 over there. So that's effectively what we're going to do, and that's going to go into the learning process. And with that, we can kind of like shovel through with our block sizes through the rest of it. So that's a good example, I think, of the block loop of how it works in that respect.